Welcome to my. Today we are going to solve one DFT problem using the FFT algorithm. Okay, so already we solved the 2-3 problems using this DIT algorithm and DIF algorithm. So now we are going to solve one more problem using this DIT and DIF algorithm. So you see the question: obtain the DFT of the sequence x of n equal to 4 ones and 4 zeros. Okay, so x of n equal to 4 1 4 0 using DIT and DIF algorithm. So this is our given question. So in order to solve this question, first you should know about how to draw the 8-point butterfly diagram for in DIT algorithm as well as DIF algorithm. Okay, so if you want to learn how to draw the butterfly diagram, 8-point butterfly diagram and 4-point butterfly diagram, already that is in our playlist. Already one video is there. If you want to learn that video, I will give the link for that video in the description box. You can refer it. Okay. So here you see the sequence x of n. This x of n consisting of 8 samples. Okay. So the capital N equal to 8. So we have to use it the 8-point butterfly diagram. Okay. So we are going to solve the problem in two methods. One is DIT FFT algorithm as well as the DIF FFT algorithm. Okay. So first one, we are going to solve it in DIT FFT algorithm. So in order to solve it in DIT FFT algorithm, first we have to draw the butterfly diagram. So you see, this is the butterfly diagram, 8-point butterfly diagram. So you know, if the capital N equal to 8 means the 8, it can be written as a 2 to the power 3. Okay. So that power 3, that 3 indicates number of stages. Okay. So you see here, this is the first stage. Okay. This is the first stage of butterfly diagram. This is the second stage and this is the third stage. So if 8-point butterfly diagram means there are 3 stages. Okay. And you know, in DIT algorithm, this is the input x of n. Okay. So input, we have to give it in a time domain sequence. And this is the output, capital X of k, it's a frequency domain. Okay. So x of n is our time domain input sequence. X of k is a frequency domain DFT output. Okay. So in order to that is so and in DIT algorithm, you know, the input x of n, we have to give it in bit reversed order. Okay, so that's why the first input applied to this butterfly diagram is x of 0, and this is x of 4, x of 2, x of 6, x of 1, 5, 3, 7. Okay, already I explained how to remember this in that 8-point butterfly diagram. So I will give a link in the description box. You can refer it. Okay. So first we have to apply the input sequence. So what is this x of 0? X of 0 means this is the x of n value at n equal to 0. Okay. So this is the x of 0. This is x of 1, x of 2, x of 3, 4, 5, 6, 7. So here input, we have to give it in bit reversed order. Okay. So the x of 0, what is the value? 1. Okay, this is the first sequence. And x of 4, which one is x of 4? This is x of 0, x of 1, x of 2, x of 3, x of 4. This is the fourth one. Okay, x of 4. So x of 4 value is 0. Similarly, x of 2. X of 2 means this one. Okay, this is 0, 1, 2, 3. So 2 is 1. And x of 6 is 0. X of 1 is 1. X of 5 is 0. Similarly, x of 3 is 1 and x of 7 is 0. So we have to give the input in a correct way. Okay, so then only this problem is correct. If the first step, that is if you just apply the x of n not in bit reversed order, okay, so then the problem is totally wrong. So we have to in bit reversed order only, we have to give the input. Okay, so then the first step is we have to find output of this first stage. Okay, so you see this is the first stage of butterfly diagram. So here this dot indicates, here there is an adder is there. Okay, so this each dot indicates in the output side, the adder is there. So you see, we have to find output in this stage. Okay, so the output, what are all the signals coming to this adder? So you see this x of 0. What is the value of x of 0? 1. Okay, so 1 is coming here. Okay, 1. And what is the another one input? So you see, the another one input is here. The x of 4 multiplied with the total factor W8 power 0. So already you know the W8 power 0 value is simply 1. So 0 multiplied with 1, 0. Okay, so that 0 is coming here. So here 1, here 0. So this 2 value we have to add. So 1 plus 0, 1. Okay. Similarly, we have to find output in the second line. So you see here adder is there. So for this adder, what are the 2 inputs? So you just see this 1. Okay, x of 0, the value is 1. And another one, you see, this is the line. So here minus 1 multiplied with the W8 power 0 multiplied with this x of 4. So here the x of 4 value is 0. So 0 multiplied with 1 multiplied with the minus 1. Anyway, it's a 0. So in lower line, the that is the signal coming is 0. In the upper line, 1. So 1 plus 0, answer is 1. Okay, so similarly, we have to find answer for this one, this third butterfly and fourth butterfly. So here you see the input applied to this 2 butterfly is 1, 0. Similarly, you see the next set of butterfly, here also 1, 0. Here also 1, 0, 1, 0. So that's why the same output you can get for this first butterfly. Okay, so for this first butterfly, what is the output we can get? 1, 1. Since input is 1, 0. Similarly, here also, if the input is 1, 0 means the same output 1, 1, it will come. Okay, similarly, the same output 1, 1, 1, 1. Okay, so the first stage answer we calculated. Okay, then the next one, this first stage answer, we have to give it to the input of the second stage. Okay, so here this is the 4-point butterfly. So there are 2 4-point butterflies there. So here you see in 4-point butterfly, the first 2 line, in first 2 line, there is no multiplier in between that. So the same one is coming here. Similarly, the same one is coming here. Okay, but here you see this one multiplied with 1 Twiddle factor. What is this Twiddle factor? W8 power 0. So the W8 power 0 value is 1. Okay, so 1 into 1, 1. Similarly, here the Twiddle factor W8 power 2. Okay, so you know the value of W8 power 2, it is a minus j. So 1 multiplied with a minus j. Okay, so in the second stage, this first 4-point butterfly, the input is 1, 1, 1 minus j. Okay, similarly, you see the second set. For the second set also, the same input is given. Okay, same for 1. So that's why in the first 2 line, there is no multiplier. So this one is coming here. And this one is coming here. Similarly, this one multiplied with the W8 power 0, the same one. Here 1 multiplied with the minus j. Okay, so the second stage input we calculated. Okay, so then for the second stage, we have to find the second stage outputs. Okay, so you see in second stage also, in order to find out the second stage output, so here this dot. Okay, in dot, what is the thing available? Adder. Okay, so in each dot, there is an adder is, you just assume it. So we have to find out the value in the each adder. Okay, so now you see the first adder. For this first adder, what is the first input? Okay, the top line 1. Okay, and what is the another line? So here you see, this is the 1. Okay, 1. So here also 1. In third line 1. So 1 added with 1. So the answer is 2. Okay, similarly in second line you see. So in second line, the thing is, okay, so the second line you see, this is the 1 value. So 1 is coming here. Okay, here 1. Here you see in fourth line minus j. So 1 added with a minus j. So the answer is 1 minus j. Okay, so in second line, the answer is 1 minus j. Similarly, in third line, you see, in third line, here 1 is coming. Okay, and here you see 1 is coming. And here 1 multiplied with a minus 1. So 1 minus 1. So 1 minus 1, it is 0. Okay, so you see 1. Here 1 multiplied with here minus 1. So 1 minus 1, 0. Similarly, in fourth line, you see 1. Okay, here 1. Here minus j multiplied with a minus 1. So minus j multiplied with a minus 1 plus j. So totally answer 1 plus j. Okay, so in second stage, this first 4-point butterfly is having the answer 2, 1 minus j, 0 and 1 plus j. Okay, similarly for this 4-point butterfly also, you see, you check the input. Okay, so if the inputs are 1, 1, 1 minus j. Similarly, for this butterfly also 1, 1, 1 minus j. So that's why you can get the same set of answer. Okay, so the answer you just copy 2, 1 minus j, 0 and 1 plus j. Okay, so or in the same manner, you just solve it. So the second stage answer we calculated. Okay, so then the second stage output, we have to give it to the third stage. Okay, so before that, we are having the 4 twiddle factor in the lower 4 lines. Okay, in the upper 4 line, there is no twiddle factor. So that's why the same 2 is appearing as an input to the third stage. This 1 minus j is appearing as it is. 0 is appearing in third line. In fourth line, 1 plus j. And in fifth line, you see the 2 multiplied with W8 power 0. So W8 power 0 value is 1. So the same 2 is appearing here. Okay. Then here 1 minus j multiplied with twiddle factor W8 power 1. Okay. So already you know the value of W8 power 1. What is W8 power 1? W8 power 1 is nothing but 0.707 minus j 0.707. Okay. So you just multiply this 1 minus j with this twiddle factor. Okay, so if you want to do the calculation, use it here. So here I am assuming the multiplication of this two answer is here the answer I am taking as some variable a. Okay, so this a value I calculated separately here. So you see the a value is nothing but 1 minus j multiplied with 0.707 minus j 0.707. Okay, so you just multiply. So first 1 multiplied with 0.707, 0.707. Then 1 multiplied with minus j, so minus j 0.707. Then minus j multiplied with the 0.707, minus j 0.707. Then the minus j multiplied with the last term. So minus of minus plus j into j squared is minus 1. So that's why minus 0.707. Okay, so here you see 2 imaginary part, 2 real part. Okay, so this plus 0.707 and minus j 0.707 cancel. Okay, real part is completely cancelled. Then if you are adding this 2 imaginary part, you can get 2 times 0.707. So the answer is minus j 1.414. Okay, so the answer available in this point A is minus j 1.414. Okay, so you just write here minus j 1.414. That is the answer available in this sixth line. Okay. Similarly, for the seventh line, you see. So for the seventh line, so here you see 0 multiplied with W8 power 2. So anyway, 0 multiplied with any value is 0. Okay. Similarly, in last line, you see 1 plus j multiplied with W8 power 3. So the W8 power 3 value is minus 0.707 minus j 0.707. Okay, so the value, you see the difference between W8 power 1 and W8 power 3. W8 power 1 is 0.707 minus j 0.707. W8 power 3 is minus 0.707 minus j. Okay, so this real part is changed. So the multiplication of this 1 plus j with this W8 power 3, you just calculate separately. So you see, this is the answer B. Okay. So the product of 1 plus j and a minus 0.707 minus j 0.707 is, so you just expand it. So similar to the A value, here the B values also, the real part gets cancelled. So the imaginary part, you can get the same minus j 1.414. Okay. So this B value is also, so the value in this point B, it is also minus j 1.414. Okay. So the value calculated. Okay. So the third stage input is calculated. Then we have to find output of this third stage. Okay. So here you see, so in third stage, so let us assume, so in each dot, okay. So here this dot indicates, in output line, this dot indicates the adder. So for this first adder, you see, what is the first input? 2. Okay, so this is the 2. And what is the another one input? So you see, this is also 2. So 2 added with the 2. So the answer is 4. Okay. Similarly, you just see the next one. Okay, so the next one is here 1 minus j. Okay, 1 minus j. And here minus j 1.414. So 1 minus j added with minus j 1.414. So the answer is real part is 1 and the imaginary part here minus j1, here minus j 1.41. So if you are adding minus j 2.414. Okay. And in the third line, okay, so the third line you see, so third line, if you are tracing here 0, okay, one input is 0 and what is another one input? This input is also 0. So 0 added with the 0, 0. Okay. Similarly in fourth line, okay, so fourth line you see, this is 1 plus j and here minus j 1.414. So 1 plus j added with the minus j 1.4. So the real part is 1 and the imaginary part here plus j1, here minus j 1.41. So if you are subtracting, you can get 1 minus j 0.414. Okay, so the fourth output calculated. Similarly, we have to calculate the fifth output. So fifth you see here 2. Okay, so the first input 2. Then here you just trace it 2 multiplied with minus 1. Okay, so in the lower 4 line, there is a scalar value minus 1 is there. Okay, so the 2 multiplied with the minus 1, minus 2. So 2 minus 2, 0. Okay, similarly in seventh line, you see 1 minus j, okay, multiplied with minus 1 multiplied with this a value. What is the a value? A value is minus j 1.414. Okay, so minus j 1.414 multiplied with the minus 1 plus j. Okay, then you just add it with 1 minus j. So you can get the answer is 1 plus j 0.414. Similarly, in seventh line, you see 0, here 0. So 0. Then in the last line, you see 1 plus j, here b value. B value is minus j 1.414 multiplied with the minus 1. So minus minus plus. So we can get the answer 1 plus j 2.414. Okay. So we calculated that 8 answers. Okay. So that's all. This is the thing. So now you see here in DIT algorithm, already you know, in DIT algorithm, the input we have to give it in bit reversed order, but output we can get it in a natural order. Okay. So this is the first output. This first output is a capital X of 0. Okay. The second output is a capital X of 1. This is X of 2, X of 3, X of 4, X of 5, X of 6, and X of 7. Okay, so therefore, finally, you just write it as the DFT of the given sequences. Capital X of k is equal to 4, 1 minus j 2.414, 0, 1 minus j 0.414, 0, 1 plus j 0.414, 0, and 1 plus j 2.414. Okay. So now we are going to check the answer. Okay, so all DFT problem, it obeys this property. So for any problem, if you are taking the DFT, the first answer. Okay, so you see the first answer, this first answer is 4 here. Okay, for this problem 4. So what does this 4 means? This 4 is nothing but it is an addition of the samples given in the time domain sequence. So what is our problem? X of n is 4 ones, 4 0. So you just add all samples. Okay, if you're adding all sample, what is the answer? 4. Okay, so in any DFT answer, the first answer is nothing but addition of this all X of n value. Okay, then except this first answer, so here 8 answers are there. So you just leave it this first answer. So the remaining is the 7 samples. Okay, so in 7 sample, you just find the center value. So in 7, this is the 1, 2, 3. Here you just leave 1, 2, 3. So this is the center value. Okay, so this is the center value. So with respect to this center value, this 2 sequence, you see, this 2 sequence must be complex conjugate. What does it mean by complex conjugate? If this data is A plus JB means this data, it will be A minus JB. So you just check it. Here the real part is 1. Here also real part is 1. Here imaginary part you see minus J 0.414. Here you see the imaginary part plus J 0.414. Okay. So this 2 data must be complex conjugate. Similarly, you see the next 2 answers. Okay. So the next 2 answer you see this is 0, this is 0. So 0, 0, it's a complex conjugate. Then this 2 data. You see this is the 1 minus J 2.414. This is the 1 plus J 2.414. Okay. So that is the first answer is the addition of all our time domain sequence. Except this, you just find the center value. About this center value, these two sequences must be complex conjugate. Okay, so all DFT answer, it obeys this property. Okay, so for any problem, the DFT answer is like this only. Okay, so in a way, you just check your answer whether we solved the problem in a correct manner or not. You just check it. Okay, so this is the DIT algorithm. So now we are going to solve the same problem using DIF also. Okay, so you see, this is the 8-point DIF butterfly diagram. So already you know the difference between DIT diagram and DIF diagram. Okay, so in DIT decimation in time algorithm, the first stage consists of 2 butterfly. The second stage consists of 4 butterfly. The third stage is consists of 8 butterfly. But in DIF algorithm, you see, this is the DIF algorithm. In DIF algorithm, the first stage 8-point butterfly, second stage 4-point butterfly, the last stage is a 2-point butterfly. Okay, so that is in reversed order. And another one difference is that in a DIT algorithm, input, okay, input x of n, we give it in a bit reversed order. Output available in a natural order. But in DIF algorithm, you see, the input we have to give it in a natural order. Okay, as it is, the 4 1 4 0 you just give. Okay, so here you see 1 1 1 1 0 0 0. So input, the first input is x of 0, second input x of 1, x of 2, x of 3. So input we give it in a natural order, but output you see capital X of k is available in a bit reversed order. Okay, so the first output is capital X of 0. The second output is capital X of 4. This is x of 2, x of 6, and so on. Okay, so output is in bit reversed order. Input is in natural order. And another one difference, in DIT algorithm, this total factor, you see, this is the total factor, W8 power 0, 8 power 1, 2, 3. This total factor is appearing before the butterfly. Okay, each butterfly stage, the total factor is appearing. Okay, you see, in the second stage, before. Okay, in third stage, before butterfly. But here you see, the total factor multiplication is available once we completed this butterfly diagram. Okay, in the first stage, you see, after calculating this 8-point butterfly, we have to multiply with this total factor. Similarly, you see here, after calculating the 4-point butterfly, we have to multiply the total factor. And here also. Okay, so this is the another one difference. Okay, so now we are going to solve this problem in DIF algorithm. So the input, as it is, we applied 4 1s, 4 0. Okay, so the first step is we have to find the output in the first stage. Okay, so here this dot indicate the add. So here you see what is the input? Here 1 is coming. Similarly, here 0. Okay, so 1 plus 0, 1. Similarly, in second line, you see, this is the 1 and 0. Okay, so 1 plus 0, 1. In third line, 1. Here 0. So 1 plus 0, 1. Similarly, 1, 0. Okay, 1. So the first 4 datas are 1. Okay, and another one, then the fifth line. Okay, so you see the fifth line. In fifth line here 1. Okay, here you see this is 1. 0 multiplied with minus 1. Okay, so anyway 0 multiplied with any value 0. So 1 with 0, 1. Okay, similarly here 1, 1. Here 0 multiplied with anything 0. So same 1. Similarly here also 1, 1. Okay, so the first stage answer we calculated. Okay, so after calculating the first stage answer, we have to multiply. We have to give it to the second stage input. Okay, so in the second stage, you see in first 4 line, there is no total factor. So the same 1 is appearing here, here 1, 1, 1. But here there is a 4 total factor is there, we have to multiply. So 1 multiplied with W8 power 0, W8 power 0 value is 1. So the same 1 is available here. And here 1 multiplied with W8 power 1. What is the value of W8 power 1? Already you know, 0.707 minus j 0.707. So 1 multiplied with this. So 0.707 minus j 0.707. Okay. And here 1 multiplied with W8 power 2. W8 power 2 value is minus j. So minus j. Similarly, 1 multiplied with W8 power 3. So W8 power 3 value appearing here. Okay, so input calculated. Similarly, we have to find the output in second stage. So you see here, okay, so 1, 1. Okay, so 1 plus 1, 2. Similarly, 1, here 1. So 1 plus 1, 2. So in third line, you see 1, 1 multiplied with a minus 1. Okay, so here I'm changing the color. So you see here 1. Okay, this is 1. Here 1 multiplied with minus 1. So 1 multiplied with minus 1, minus 1. So 1 minus 1, 0. Similarly, 1 multiplied with 1 multiplied with the minus 1. So 1 minus 1, 0. So 2, 2, 0, 0. Okay. Similarly, in this stage, okay, so in previous diagram, if inputs are same means output is same. Okay, but here you see in this 4-point butterfly, the input is 4, 1. But this 4-point butterfly, the input is different. Okay, 1, 0.707 minus j 0.707 minus j, this one. Okay, so this output, it will not come as an output to this stage. Okay, we can calculate. So here 1 added with a minus j. So 1 plus j, so 1 minus j. Similarly, 1, sorry. Here you see 0.707 minus j 0.707 added with minus j minus 0.707 minus j 0.707. Okay, so that's why this plus 0.707 minus j 0.707 cancel. Then minus j 2 times. So minus j 1.414. Okay. Then in third line, okay, so third line you see here minus okay, here 1, 1, here minus j multiplied with the minus 1 plus j. So 1 plus j. Similarly, 0.707 minus j 0.707 added with minus of, okay, you just trace it. Here you see 0.707 minus of this one. Okay, so minus of here is plus 0.707 plus j 0.707. Then you add it, you can get the answer 1.414. Okay, so the second stage output calculated. Then we can transform it to third stage. So for third stage, in first 2 line, there is no multiplier. So the same 2 is appearing here. But here 0 multiplied with the W8 power 0, 0. So 0 multiplied with the W8 power 2, 0. And here also no change. 1 minus j as it is you write. The minus j 1.414, you just as it is you write. Then here 1 plus j multiplied with the W8 power 0, 1 plus j. Here 1.414 multiplied with the W8 power 2. W8 power 2 is minus j. So minus j 1.414. Okay. So the input applied to the third stage is calculated. Then finally we have to find the output. So here you see in dot 2 plus 2. So 2 plus 2, 4. Here 2 multiplied with minus 1. Okay, so 2 minus 2, 0. Similarly here 0, 0, 0, 0, 0, 0. Okay, similarly here 1 minus j added with minus j 1.414. So 1 minus j 2.414. Similarly here 1 minus j added with minus of minus plus. Okay, so 1 plus j 0.414. Similarly here 1 plus j minus j 1.414, you just add it. So 1 minus j 0.414. Here 1 plus j minus of minus plus j 1.414. So 1 plus j 2.414. Okay, so the answer calculated. This is the DFT answer. But here in DIF algorithm, this x of k is not in a natural order. It is in bit reversed order. Okay, bit reversed order means the output appearing in the first line is capital X of 0. The output obtained in the second line is not X of 1. It is a capital X of 4. Okay, this is X of 2, X of 6, X of 1, X of 5, X of 3 and X of 7. Okay, so then in natural order, you just write it, you rearrange and you write down the answer. So the DFT DFT of the given sequence is x of k equal to 4, comma, this is x of 0, this is the x of 1 value, this is x of 2, this is x of 4, 3, this is 4, 5, 6, 7. Okay, so in natural order, you just write. Okay, so after writing, you just check our answer is correct or not. So you see the first answer. What is this first answer? This first answer is nothing but the addition of our time domain sequence. Okay, if you are adding this time domain samples, we can get the answer 4. Okay, then except this first answer, you find the center value. This is the center value. This 0 is the center value. So about the center value, this 2 to datas. Okay, this 2 is a complex conjugate. Next 2 is a complex conjugate. Next 2 is a complex conjugate. You just check the answer. Yes, it is a correct. Okay. So in any way, for the same problem, if you are calculating the DFT in a DIT algorithm, DIF algorithm, or in in this direct evaluation method, in any way you can get the same answer. So you see the x of k obtained in DIT algorithm, the same answer is available here. Okay, so that's all. This is the problem DFT of the sequence 4140 using DIT and DIF algorithm. Okay, so already we solved that is the 3 problems using this DIT and DIF algorithm for different data. Okay, 8 ones, then 1 2 3 4 4 3 2 1. So it is a very important repeated university question. Okay, so you just learn. If you want to learn that video also, I will give link in the description box. You can refer it. Okay, so thanks for watching my channel, and please subscribe my channel for more videos. Thank you. We will meet in the next video.